Okay, are we good?
Yeah.
Okay, so basically, we're going to talk about test instruments and a little bit about soldering. The probably most common piece of test equipment that you will have, and you probably should have, is a multimeter, which combines a voltmeter, an ohm meter, and usually an ammeter all in one handheld device. So you can use it to measure volts. You can use it to measure resistance in ohms, or you can measure current in amperes. Typically, they may go up to 10 or 20 amps on most of the multimeters. You may have to actually change where you plug the test lead in for the higher currents. In some cases, they have a lot of other functions where they'll measure the gain or HFE on a transistor. They'll measure temperature. Some cases, they may measure capacitance. There's a lot of additional functions they keep adding because there's a little processor in that, even the cheap multimeter. Probably the biggest mistake is trying to measure a voltage when you've got it on a resistance setting. And most of them aren't smart enough to compensate for that. And you'll either blow a little internal fuse, which you can replace, or you wind up replacing the multimeter. Here's a picture of a couple typical, not what you'd find on eBay. The one on the left is a more modern digital multimeter. And the one on the right is sort of the old standard analog multimeter, the old Simpson, which
That was standard equipment on every bench when I was in the Navy.
Yeah.
works today.
And it
Yeah.
does, yes, it does.
and you can find them at the Ham Fest. I don't know if they still make them, but they still are around. You can buy them, but they cost as much as the one on the left. But they're really good. And there are some advantages to having an analog meter because you can see the needle move as things change. You can't really do that with the digital. Which of the following measurements are made using a multimeter?
That's on the meter.
The,
Of the
Yeah.
choices they give you.
well, that would be delta, yeah.
No, I haven't seen any that'll measure signal strength or noise.
Oh. Told you I like delta.
Yeah, I know you like Delta, but this isn't a Delta.
It's not today.
It's a Charlie. We only
Alright.
had one Delta today, I think.
Oh,
Which of the following can damage a multimeter? Read the answers carefully.
Yes. One much.
It's not Delta.
well, now it seems like that Alpha and Charlie are just,
Well, read them. They're not the same.
Alpha. We're having a major thunder and lightning storm here. I don't know whether you know that or not.
Where are you?
Texas.
Oh,
Uh,
We're having one of our very rare rainstorms.
oh, maybe it's caused by the CME. Can you see the aurora?
No. Mm-mm.
Probably have to be out at night.
We haven't. It's been kind of cloudy here for a few days.
Okay. Well, all right. The answer was Charlie.
Their voltage when using the.
Trying to measure voltage when you got it on the resistance setting.
You wouldn't know what it says.
If you were trying to measure resistance on the voltage setting,
That's it.
nothing would happen.
She's getting hammered right now.
mhm.
I said the map is hammered right now.
Using the resistance setting. Okay.
Midland or this? No.
Read the answers.
Okay, so the voltmeter part of the multimeter, or it could be a separate instrument. In some cases, there's laboratory voltmeters that are very precise, which you might find in a lab, on a bench top. Although today, most of the handheld multimeters are plenty good enough. Basically, they're measuring electric potential between 2 points. So it's a parallel connection. Whereas when we talk about in the next slide or two measuring current, it's a series connection. You actually have to put it in the circuit.
Mm.
They'll have different settings for voltages. In most cases, they have separate settings for DC and AC, unless it's a really smart one and it can switch. Like I showed, it could have an analog or a digital display. It will, in most cases, be in volts, unless it was one of those laboratory ones where it might be able to measure microvolts or something like that, specific for doing very low voltages. It appears to be a very high resistance to the circuit. So when you put it in parallel, it shouldn't have a significant effect on the voltage reading, even though it will have some. According to Heisenberg, you can't measure anything without affecting it. So you want it to have as high a resistance as possible when you put it in parallel. That was why they went from the old voltmeters, which was pretty simple, to a vacuum tube voltmeter, which had a very, very high input impedance because you were feeding the signal into the grid of a vacuum tube. So it looked like a extremely high impedance, since that's a voltage controlled device. And you also want to make sure that you've got a unit that's rated to measure the voltage that you're trying to measure. Usually the handheld ones will only go up to like 700 volts.
On 600, yeah.
So if Heisenberg is right,
Yeah.
I'll be able to make a better observation, a more accurate observation if I have a smaller eye, or what?
Perhaps. Whatever has the least effect on the measurement.
Well, I make a lot of observations with my eyes, so, you know.
Well,
Well,
But I think he was also talking about you couldn't measure the mass and the velocity of the photon at the same time.
That's
You got one or the other?
Great.
Which instrument would you use to measure electric potential?
Bravo.
Bravo. How is a voltmeter connected to a component to measure applied voltage?
Oh, everything's gray now. And the answer side.
Alpha,
Now, you weren't listening.
no, I wasn't.
In parallel,
Okay,
you put it across the 2 points that you want to measure. Which of the following precautions should be taken when measuring high voltages with a voltmeter?
Bum, 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 bum,
um,
bum, 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 bum. We were on a roll with Bravo a minute ago. I mean, precaution.
well, that's what I would say would be Bravo.
Well, you know what? You're right. Okay. Next comes the ohmmeter portion of the multimeter. This again could be a separate device. Usually it's something like what they call a Wheatstone bridge, where you can make a very precise resistance measurement, but you kind of have to measure something out of the circuit. In other words, you can measure an individual resistor on a separate Wheatstone bridge device. The way they normally work is supplying a fixed current. So that's why it has to be in series. So it has a constant current source, and it feeds that current through the device you're measuring, and it reads the voltage generated across it. So it's basically using Ohm's law. So I times R gives you E, so it's measuring E, and it knows what I is because it generated I. Therefore, the answer is R. They can be both analog or digital. Normally, the scale will come up in ohms when you're measuring resistance. If you're measuring a circuit, and because this is in parallel, so could be other components in the circuit. If there's a large capacitor, it's going to have to charge that capacitor up. And since it's a fixed current source, it's going to take some time. And you'll see the reading change as the voltage goes up as it charges it. And likewise, if you had a very large inductor, like a big transformer or something, you can actually see it decrease due to the inductor charging, storing some energy in the field. And like we mentioned earlier, you want to make sure that the circuit's not powered. In other words, you're not trying to measure resistance when there's a voltage present, because that tends to mess it up. Makes you have to go buy a new one. How is an ohmmeter connected to a component to measure its resistance?
Well, the other one, I would say Bravo.
I would ask someone with experience like Alan.
What did you say?
I would ask someone with experience like Alan.
Yeah. I don't even remember what the last one was. I think it was,
You measure voltage in parallel.
parallel, so this would be in series.
No,
No? Oh, there's
no.
only one that's in series.
Uh,
Yeah, it's in parallel.
Current is in series. We haven't got there yet. That's next.
I know, yeah.
Okay. Which of the following precautions should be taken when measuring in circuit resistance with an ohm meter?
Bravo.
Bravo, right.
Well,
What
that's
reading-
something, right?
What reading indicates that an ohm meter is connected across a large discharged capacitor?
Discharged. Is Alan our expert?
Yeah, you wouldn't want to put it across a charged capacitor.
Is Alan our expert? I think Alan is our expert.
Put it across the chart, but you can put-
They're not that bad.
yeah,
I need Jeff all the time.
So remember, the capacitor, when it's discharged and you supply a current, it's going to initially appear like like a zero resistance until it charges up. And when it's fully charged at whatever voltage you've applied, then it's going to look like an infinite resistance.
So this would be, from what I'm understanding you're saying,
Did you say alpha?
yeah, I was fixing to, but from what I'm understanding, I would say alpha, yeah.
Okay, you understood it right. As it charges up, it's going to appear that the resistance is increasing
Yeah,
up to whatever the circuit resistance is. It's initially going to look like it's zero. And then it's going to increase until it gets up to whatever the equivalent resistance is. Okay, here comes your ammeter, and we're going to measure current in a circuit. In order to do that, we have to put it in the circuit, so it's got to be in series. I guess the only exception would be if you were talking about an AC ammeter, where you clip it over the wire and it measures the current via induction. But we're not talking about one of those. So for your multimeter, the ammeter function, you've got to put it in the circuit in series. Again, it can be analog or digital displays. Normally it will be in amperes. Some of the other scales might actually say milliamperes. And you need to make sure that it's rated for the current you're trying to measure. Most of them limits you to 10 or 20 amps. So if you were trying to measure 100 amps, you probably need a different device. And if you put that kind of current through it, you probably would be buying a new one of those also. What instrument is used to measure electric current?
Charlie.
One, what Mr. Ampere would use.
I don't know what he had.
Yeah.
They had those funny looking instruments. I think they called them galvanometers.
Galvanometer.
Yeah, and it measured current.
We
Sure.
haven't
And
covered
that's
that.
what Mr. Ampere used.
I think so.
He must have been dedicated.
Well, let's see what it is. Let's try an ammeter, named after Mr. Ampere, to measure current in amperes.
But we're English, so we're not gonna do the Frenchy thing.
All right. When configured to measure current, how is a multimeter connected to a component?
Alpha.
All right.
Yeah.
Okay. The last part is a skill that you may or may not need to use depending on what part of the hobby. If you like to build stuff, you'll have to learn how to solder. If you want to do your own coax cables and put connectors on them, in most cases, you need to at least solder the center connector. They say it's an essential skill. Like I said, it depends on whether you want to build stuff or not. If all you want to do is operate, you don't have to know how to solder. If you do, you want to make sure you use rosin core solder, not acid core that's designed for doing plumbing. One of the main things in soldering is to heat the components, usually a wire and a terminal that you're trying to solder, together at the same time, okay, until the solder flows. And sometimes it's not as easy as it appears to get the soldering iron where you're heating both of the components, or maybe even more than two, at the same time. You also want to make sure that you've cleaned the stuff. If you're trying to solder some old wire that's tarnished, or connectors or something that were silver plated and they're black now, you probably need to clean it a little bit or use an awful lot of flux.
Even if I'm gonna make sure tip on your iron is clean.
Yeah. You should tin it frequently.
Um,
I found this nice little, almost like a little pill case full of this tinning stuff, which
mhm.
is a powdered
Borax.
tin, I think.
Okay.
It's a little gray powder. You just stick the iron in there and it's just melts it right on there. Nice and shiny. So when you solder, the joint that you make, okay, should be nice and bright and shiny. Should smooth, kind of usually a teardrop or Hershey Kiss kind of shape, and should be nice and shiny. If it's dull looking, has a grainy texture, lumps on it, it's dark, it means it's a bad solder joint. You probably didn't get it hot enough for the stuff to flow, because when it first starts to melt, the solder softens and kind of makes little chunky things, but it doesn't flow onto the other connectors. So you're just melting a blob of solder. You're not making a connection.
So it flows.
And sometimes you can go back and reheat it and fix it.
So
But if you do it too many times, you do it on a circuit board, then you find the copper coming up. Which of the following types of solder should not be used for radio and electronic applications?
Alpha.
Alpha. What's the characteristic appearance of a cold tin lead solder joint? It's your favorite one, Brenda.
Well, we didn't cover a cold lead solder.
Well, we talked about a bad solder joint.
What would we say? Let's see. Which is the characteristic appearance of a cold tin lead solder joint?
Yeah.
Well, I just offhand, I would say Charlie, but you indicated that it was Delta. So which is it?
Well,
my friend Lumpy knows.
Well, that's what The rough and lumpy was what I would be saying, yeah.
There you
Charlie.
go. Because we said that, get back to it. We said that a bad joint looks dull, grainy, or lumpy.
Yeah, but you didn't say, where is tin, lead and stuff in there? There's nothing there.
Well, okay, you're right. It's because solder is a mixture of tin and lead.
Well, it didn't say that.
Well, all right, I'm telling you now, so you know. Most solder is either 60-40 or 63-37 ratio of tin and lead.
Sometimes.
Okay.
When
The-
you, when you get to talking to people like Bob and I, who have spent our entire careers working in electronics, that to us sometimes might seem like it's, common knowledge. But so we probably forgot to just add that part in here somewhere that.
Kind of assume everybody knows what solder
Yeah.
is.
So we apologize for that. And
Well,
yeah, and the same thing with cold solder joint. I mean, he said here on the bullet points, he said a bad solder joint looks dull, grainy, or lumpy. And the classic term for a dull, grainy, lumpy solder joint is a cold solder joint, which means the solder didn't get hot enough.
yeah,
So to one or both of the items being soldered together, it may not have bonded properly. And later on down the road, that's gonna cause problems.
well, see, I've soldered quite a bit doing the things that I do, but I don't know the compound, I
Right.
didn't know what it was made up as, so.
Okay,
Well, the next time you solder, look at your roll of solder and it should tell you what percentages of tin and lead.
I just never noticed, I guess.
unless.
And in fact, it could have a little bit of silver in it.
Yeah,
Yeah.
That's what I was gonna say.
Yeah,
In fact, the stuff they're kind of recommending now for doing the surface mount things has 2 or 3% solder in it. Silver, I mean.
silver, okay, yeah.
I think that helps it melt at a lower temperature.
Hmm.
Normally, we always use 63-37 because that has the lowest melting point. Slightly lower than if it was just a standard 60-40 solder.
So, the silver solder, used to be used and it's used like in jewelry and some things like that.
Right.
What is its normal composition?
Well, anywhere from pure. I'm not sure what they add to it.
Yeah,
I haven't done any silver
I
in a
know.
while.
I know I used it making search instruments.
Yeah.
Making little cauterizing needles and things like that.
Hmm.
If you need to solder like steel and stuff like that together, normally you'd use silver solder.
Well, I hope it's not too much Senate, considering how much silver has gone up recently.
That you can go from 6%, 15% flows a lot better.
Yeah.
And it's about 2,000 degrees.
So the 15% flows better than the 6%.
Way better.
Okay, so it's Charlie.
Right.
Probably what I was using making search instruments.
Okay, so multimeters measure voltage, current, resistance. You want to remember to never measure a voltage when it's on the resistance setting. That also means that you never try to measure resistance when there's a charged capacitor in the circuit, because that's going to have a voltage on it. The voltmeter portion measures electric potential between 2 points, and you connect it in parallel with those 2 points that you're measuring. Again, need to make sure that it's rated for the voltage you're trying to measure. Said most of the multimeters I've seen go up to about 700 volts,
Huh.
and somewhere in that range on both AC and DC. You connect the ohm meter in parallel also, because it has to provide a current so that it can measure the voltage generated across the component. And you're actually, when you do it in a circuit, you're measuring the equivalent resistance of everything in that circuit. So if there's other thing connected to that resistor, you may not just be reading the resistance of the resistor itself.
Yeah,
Is that
you're
gonna
reading through a complex circuit of series and parallel paths and other components besides that. So the best way to do it is with through-hole components, it's simple, because you just raise one lead. You just unsolder and raise one lead, and it isolates it from the circuit, so you can get an accurate measure through just that component. With surface mount components, like on Bob's board, circuit board there, it comes a whole different problem.
Mm.
Well, you have little tweezers you use. And in the ammeter mode, okay, you're measuring current in amperes, and you connect it in series with the circuit or the component that you're trying to measure. And in soldering, you want to make sure you use rosin core if you're doing circuit work, electronics. Acid core is for doing plumbing or similar type non-electronics. Make sure you have enough heat or big enough iron or broad enough tip that you can transfer the heat to get good flow. If you're trying to solder a very large component and you've got the smallest conical tip on your soldering iron, it's going to take forever to transfer that heat. So you really need to have a soldering iron where you have replaceable tips, so you can select the tip depending on what you're doing. And if you're, when you do solder, you need to inspect the joint and make sure that it's bright and shiny. If it's not bright and shiny, it means that you have a bad solder joint, probably because it's a cold solder joint, didn't get hot enough to flow. Or it could be that the components were too oxidized or dirty, so it's not making a good connection. You got a barrier there. And sometimes even enough heat doesn't seem to get over it. You really need to make sure it's clean before you start. In that case, you kind of get a lump, not necessarily grainy, but
Yeah.
you don't have a connection.
Ball up.
Okay, any questions? That was 6 easy questions we did.
I don't have any questions at the moment, no.
Okay, well, just feel free to email me or call me or whatever.
Okay, well, I'm just gonna have to go over again this last session.
Yeah, because you missed a couple,
Yeah, I did.
so you want to be able to, like I said, you want to be able to get up in the 80% range when you do practice tests.
Okay, now, is this the last one?
No,
Okay,
we have 2 more.
all right, all right. I
Okay.
thought we did, I thought we did.
The 2 more are operating procedures and rules and regulations.
Okay, all right, so since I seem to be the only one here, can I change the time?
What do you want to change it to?
Well, what it was originally.
Well, I guess we could go back to that.
Oh, it's 10 o'clock?
Yeah, because.
9:30.
half- Like I said, half the day is over with by the time 8:30 rolls around. 9:30, I mean, 9:30.
Well, maybe for you, I don't get up early, but that's fine. We'll go back to 9:30 now.
Yeah.
We're not having class next week.
Okay, well, see, this class for me is at 9:30 and half the day is over with.
No, I have to go be a VE next week,
Oh.
What is that?
a volunteer examiner.
Oh, for the testing.
Yep.
Okay.
So we'll have a bunch of people trying to get their license.
Okay. How many are doing it?
I don't know this time. Normally
We're gonna do,
we have 15 to 20 people.
Really?
Yeah.
Well, I have a question, now that we're on this subject that we're talking about, how,
To the park and operate low power,
Okay,
5 watts, 10 watts max.
and try and make connections with people.
Yeah.
All right. What's your question?
my question is,
Official time is
I've
10
been
to 2.
to,
I'm gonna try to get there before 9.
Midland,
The
which is
thing
for
that happens is that
over there.
the park becomes overflow for the beach.
Sure.
There seem to be
So
mostly
we
older
try to get there
people.
really no-
Are the younger people
That's
losing
Park
interest
at Cocoa Beach,
in this form of?
Merritt
North
Island.
Merritt Island. on-
Yeah.
I can't hardly hear you because of the background chatter.
Okay. Let her ask her question. All right.
A
Well,
lot of background chatter there, I can't hear.
okay. So say your question again.
My question is, when I went to the big meet over in Midland that they had over there a couple of months ago, there was mostly older people. Are younger people losing interest in this form of communication?
Well, I wouldn't say they're losing interest. They haven't had interest for quite a while. And around here, most of our clubs are
Mhm.
probably 50 and older. Exception being the KSC club, because they're mostly, was limited to employees, so it's a much younger crowd out there, but that's just because of where it is. The other clubs don't have many younger people, don't have many women.
Well, I can
Even-
understand why.
Well, there seems to be more interest, and I notice there's a lot more women interested in these courses. Of course, they don't follow through all the way. Get a lot of dropouts,
No, they're gone.
but and younger people are starting to get interested again. Just not around here.
This is what younger
I
people.
was
Right.
gonna say, the younger people don't probably understand the need for
I've
having something
got-
like this in a
I've got
budget.
one teenager interested.
But you know, when we
Well,
had
heck-
the when we had that cellular problem, what was that, 2 months ago?
This is mobile.
When we had the outage
Well,
and cell phones didn't work,
Portable HF.
Portable.
box.
I got a lot of people
Regular 14
that wanted to
years.
sign up
They-
in case it happens again.
That's probably important.
Okay, well, my question is, what kind of outreach programs do you have in the high school?
It's really thick.
Yeah, it looks like 14.
I don't know.
It's regular old Walmart.
It's-
speaker wire.
It's a problem to get young people interested, where back, 50 years ago, it was probably mostly young people. We got some people here in the club, Jack, who shows up a lot,
James.
got his license when he was 11. So there's a lot of people in our club where they got their license at, teenage.
Most of the younger people that are involved are, their
It's a
20s and
dipole,
30s,
you just,
and they're
yeah.
preppers. And they
the
don't.
sun
do
is right
clubs.
here, You can
It
buy.
sounds- It sounds like, I don't know if this, I hope this is not the case.
They can,
It
they're
sounds
just
like
like an
this,
X.
this maybe is,
That way, so you can wind this.
terrible
up,
to the buggy whip.
Pick it up like this,
no.
because at home, when I use this at home.
So when you went to Midland, was that a club meeting or some kind of ham fest or what?
Yeah, it was a ham fest,
rolled
a
the
big,
rope
I
and
think their
snap this
yearly
on, and then
convention
pull
or
the two
something.
wires out and-
Okay.
And, I happen to just be,
and pull it back.
friends with somebody who is a ham
Yeah,
operator
all
over
over.
there.
This part
And I've
here
always
doesn't
wanted
get
to do
used.
this,
I just
so,
attach my.
I
rope,
said this is
and
my
then pull it
goal.
out
I
and
don't
do the
know how,
But I
how
wanted to be able
involved
to
I'm
put this
gonna
on
be
there,
able
so
to
that's why I
get
put this part there.
because
instead
of,
of just having like an X. And it ended up looking
first
big
of all,
enough to be formed in a gingerbread man.
and also the cost.
And
So that's
it's
my
the
limitations right
two
there.
fifty-nine.
Okay.
SMH female on this.
It's harder to find that.
Yeah,
That's just personal
The reason I'm
limitations.
saying is if we
And
can
like I said, I don't know how far I'm gonna be able to go with it.
obtain
okay.
cable. And then we've got.
Yeah, I don't know what the answer is right now.
No, there isn't any, because, but I do have, a lot of other, very important interests as well. This is just a goal that I have set for myself.
Okay, I'll be back in a minute.
13 to the 59.
It's the same thing. The 213 and the base of the antenna.
You should.
259 goes right in there.
Right.
Okay, so there's no connector there. We just hooked it up.
Yeah.
Is there, now the arrestor, does that go in line? when you're-
You heard him say, Brenda, that there's no class next week, right?
No, I heard
Yeah.
him say we have 2 more classes.
2 more classes, but not next week.
Yeah, next
Not
week,
next week.
you
Oh,
volunteer examining.
right, okay, all right, I understand now, okay. Well, I'm glad you clarified that for me.
No problem.
That means
Okay.
those of you aren't here, if you wanna
All right,
drop
thank you.
by the park,
Mhm.
yeah.
Yeah.
We moved to Kelly Park East during summer because we get the breeze right off the river.
Oh, the river,
Mm.
Yeah,
Real cool.
but otherwise we'll go to a park with more trees,
No, she does.
because you can throw up a wire and have a full-size antenna real easy, strung between trees.
Mhm.
The dipoles are probably the best as far as a cheap, efficient antenna. Probably your next favorite antenna, for HF is gonna be an in-fed half wave or some sort of in-fed antenna. Because you only have to raise one end
Mhm.
and you'll get multiple bands on the one antenna. But you use a transformer to feed the antenna.
Mm.
If it's a half wave, you're gonna use typically a 49-to-1 transformer. If it's a non-resonant random wire antenna, then you typically use a 9-to-1 transformer. But, yeah, the in-fed half wave, that's gonna be your next most popular antenna, because it's almost as efficient as a dipole.
That's what we're gonna use it.
But you get the, all right, this is for your VHF, that's a very good antenna. That's just for your VHF.
Yeah, we're just looking for 2 meters.
Yeah.
Okay, and then play, I'm gonna use 213 all the way down, because I don't have any bend, I got just a slight bend going in and then a slight bend going out.
Yep.
So and then Clay's got a little different scenario.
Where are you gonna put your lightning arrestor?
That's what I was gonna say, the lightning arrestor, it goes in line, in line.
You wanna have how long a coax and how far away is the antenna?
I'm looking at 50 feet.
50 feet. So you're probably gonna end up having your ground rod right before you go into the
Brenda
house.
said, she'll see you later.
Okay,
Yeah.
Mhm.
That's what I'm talking about. right there.
or
I reminded
you can
her,
have it. at
reminded
the
her that we're
antenna.
not having a class next
Where
week,
your ground rod is,
so.
that's where your lightning arrestor is gonna be.
Unless you can figure out how to start one.
If I come down with a 20-foot piece of 213 with the